Good morning, children. Welcome back to ICAN Physics. Now, in this class, we are going to study about 14th problem related with the capacitors. Okay. For the given capacitor configuration, find the charge on each capacitor, find the potential difference, find the energy stored. Okay. So, first, look at the circuit diagram. These two are connected in parallel. Okay. So, we can give the name C1, C2. So, C1 and C2 are connected in parallel. So, CP equal to C1 plus C2. So, C1 value is 6. C2 value is 2. So, 6 plus 2, 8 microfarad. Okay. Now, these two becomes 1, that it becomes CP, so that the circuit is changed. 1, 2, 3. Okay. Now, it is connected with the 9-volt battery. It will be positive and it will be negative. Now, C1, C2. Now, it can be taken as C3 and it can be taken as C4. So, it is C3. These two becomes CP, and this one will be C4. Now, these three are connected in series. So, when it is connected in series, 1 by Cs equal to 1 by C1 plus 1 by Cp plus 1 by C4. So, for instead of C1, we can write C3. Okay. Now, the value of C3 is 8. The Cp is also 8. C4 is also 8. Okay. So, that we can write 1 by 8 plus 1 by 8 plus 1 by 8. So, when we add, it becomes 3 by 8 is 1 by Cs. Now, reciprocal the value. So, when you reciprocal the value, Cs equal to 8 by 3 microfarad. Now, these 3 becomes 1. Okay. So, 1. That is Cs. Okay. Now, it is connected with the battery of 9 volt. The effective capacitance is 8 by 3. 8 by 3. Then, we can calculate the charge from the source. Okay. So, what is the charge? Charge from source. Okay. So, C equal to Q by V. Now, I want to modify this formula for our case. So, what are the things involved? Cs and Q. So, Cs into capital Q divided by V. Now, we are going to calculate only charge. So, the division V comes to this as multiplication V. So, Cs into V equal to Q. Cs, so 8 by 3 into V is 9 volt. So, Q. So, 1 3 is 3, 3 3s are 9. So, charge is 8 3s are 24. The unit of charge is coulomb. Okay. So, it is given in micro. So, it is micro coulomb. So, charge from the source is 24 micro coulomb. Now, the capacitors are connected in series. Then, the charge will be same. Charge will be same. So, the same charge will flow through C3, Cp and C4. Okay. So, we have to calculate the potential difference across the C3. So, it can be taken as V3. The potential difference across the Cp is taken as Vp. The potential difference across C4 is taken as V4. Okay. So, now what we are going to calculate? V3 or potential drop across C3. Potential drop across C3. So, we know that C equal to Q by V. Now, I want to modify the formula. C becomes C3. Q becomes capital Q. And V becomes V3. Okay. Now, we are going to calculate only the potential. So, in the division V3 comes with this as multiplication V3. So, V3 equal to Q by C3. Okay. Now Q. So what is the value of Q? 24 microcoulomb divided by C3 is 8. So 3 8s are 24. So V3 equal to 3 volt. Okay. Do you get it now? Do you have any doubts? No doubts. Now we are going to calculate. Now we are going to calculate the potential drop across the CP. So directly I want to go to this stage. So across the C3 potential drop is VP equal to Q by CP. Okay. Now where's the value of Q? 24. CP is 8. So the potential drop across the parallel capacitors is 3 volt. Okay. Next we are going to the third one, V4. So directly I go to the third stage. V4 equal to Q by C4. So Q is 24 divided by 8 is 3. So V4 equal to 3 volt. Okay. So potential drop across each is 3. So here the potential drop is 3 volt. Here also the potential drop is 3 volt. Here also the potential drop is 3 volt. So one more thing, all the capacitors having a capacitance of 8. So that the potential drop is also same. Okay. Do you get it now? Do you have any doubts? No doubts. Okay. Now we are going to calculate charge through C3. Okay. So charge from the source is capital Q. The same charge will flows through C3. So charge through C3. Okay. So C3, the same charge is flowing. So what is the value of charge? 24 microcoulomb. So Q equal to 24 microcoulomb. Okay. Now, once again, come to this stage. When the capital Q is the charge comes at this stage, then when it reaches this one, then it splits into 2, then it becomes Q1 and it becomes Q2. Okay. Now we know the potential drop here, that will be Vp. We know the potential drop, we know the capacitance, then we can calculate the value of charge. Okay. So charge through C1. So charge through C1. So C equal to Q by V. Now I want to modify the formula. So how we can modify? C1 equal to Q1 by Vp. So the division Vp comes to this as multiplication Vp. So Q1 equal to C1 into P. Okay. C1. So what is the value of C1? Is 6 microfarad. Okay. 6 microfarad. Vp, potential drop across the first one. Is Vp. So what is the value of Vp? 3 volt. Okay. So 3 6 are 18 microcoulomb. So like that I can modify the formula for Q2 case. Okay. Q2 Vp C2. So we can modify this one. So Q2 equal to C2 into Vp. Okay. C2. So what is the value of C2? 2 microfarad. So what is the potential drop? 3. So 3 2s are 6 microcoulomb. Okay. So when 24 microcoulomb is at this stage, when it splits into 2, then it becomes Q1 and Q2. Now the Q1 value is 18. Here Q2 value is 6. Okay, 18 plus 6 becomes 24. Then we can verify that our problem is correct one. Okay. So once again, these charges combine here and the same charge Q is flowing through C4. So charge through C4 is also capital Q is 24 microcoulomb. Okay. So the first case and the last case are the same. But how we can modify this one? Once again, we can calculate like this. Here we can go for Q4 equal to C4 into V 4. Okay, C4 is 8. V4, 3. 3 8s are 24 microcool. So like that we can verify also. Okay, do you get it now? Do you have any doubts? No doubts. The next part. Okay, so electrostatic potential energy. Okay, so what is the formula to calculate electrostatic potential energy? That is half CV square. Okay, so for the first capacitor, I am going to modify the formula. That is half C1 into Vp squared. Okay, so there is a first one, half into C1. So what is the value of C1? Is 6 microfarad. So 6 into 10 to the power minus 6. Okay. So what is the potential drop across that one? 3. So 3 square. Okay. So 1 2 is 2. 3 2s are 6. 3 3s are 9. 9 3s are 27 into 10 to the power minus 6 is the electrostatic potential energy or energy stored in the first capacitor. The unit is joule. Okay. Second one, for the second capacitor C2, so that I can modify this one as U2 or epsilon 2 equal to half into C2 into Vp squared. So half into C2. So its value is 2 microfarad. So 2 into 10 to the power minus 6 into Vp squared. That it is 3 squared. Now 2 are getting cancelled. So 3 3s are 9. So 9 into 10 to the power minus 6. So many joule. Okay. Do you get it now? Do you have any doubts? No doubt. Now we are going to study the electrostatic potential energy stored in the C3. Okay. So it can be taken as epsilon 3 equal to, the formula can be modified C3 into V3 squared. Okay. So half into C3. So what is the value of C3? 8 microfarad. So 8 into 10 to the power minus 6 into V3. It is 3 square. So 1 2 is 2. 4 2s are 8. So 3 3s are 9. 9 4s are 36 into 10 to the power minus 6. This much of joule. Okay. Now we are going to the fourth one. Okay. So for fourth one, epsilon 4 equal to half into C4 into V4 squared. Okay. Half into C4. So what is the capacitance? 8 microfarad. So 8 into 10 to the power minus 6 into V4. 3 squared. So 1 2 is 2. 4 2s are 8. 3 squared. So 3 3s are 9. 9 4s are 36 into 10 to the power minus 6. This much of energy. So the unit of energy is joule. Okay. Do you get it now? Do you have any doubt? No doubt.